Thank you for joining me today. I'm going to be talking to you about problem-solving distance, reflections, and reflections on the coordinate plane. All right, so first of all, let's take a look at some things you'll need to know. Mainly, what a reflection is. These are simply opposite points on a coordinate plane. So you can go back and look at the lesson on coordinate plane if you've forgotten what that is, but here's an example of it right here. That is a coordinate plane. And you can see here we've marked a couple opposites for you. These would be the points 2, 2, and 2, negative 2, okay? And these are actually reflections. And what makes them a reflection, again, is it's though these 2 points are looking at each other in the mirror, like you're looking at yourself in the mirror and you see the reflection. Now, I'll show you why that is and how this relates to their ordered pairs. And then we'll also show you how you can modify those ordered pairs to find different reflections for other ordered pairs. So let's take a look at some examples then. You can actually reflect over both axes. You can reflect over the y and the x. So when reflecting a point over the x-axis, what you need to remember to do, if you're reflecting over the x-axis, you need to change the sign of the y-coordinate. So what that means, if you look here at this example, what that means is you have 2, 3. If we want to reflect 2, 3 over the x-axis, notice that we change the y-coordinate to a negative. It was originally a positive, now it's a negative. Here's the example drawn out for you. So we originally were at 2, 3, which is right here, and we've reflected that over the x-axis to here, which makes that 2, negative 3. Okay, so just notice that changing that y-coordinate sign simply reflects over the x-axis. The next part, if we want to reflect over the other axis, which is the y, which would be left to right as opposed to up and down. You can see we're going to reflect the point negative 5, 2, and this time we're going to reflect it over the y-axis. Well, as you might assume, if you're going to change the y-coordinate for the last example, this time you're going to change the x-coordinate. So you can see here we're reflecting negative 5, 2, and the x-coordinate now, the sign has been changed from a negative to a positive. And that's actually what's going to reflect it then over that other axis. So you can see we originally started right here at negative 5, 2, and by changing that y-coordinate, or excuse me, x-coordinate, we go then to 5, 2. So remembering these little rules will help you in solving some of these reflection problems, because what you don't always get, as you can see here with these examples, is a coordinate plane to use. Now that's not to say you can't draw your own. However, sometimes it can still get a little confusing. In this case, write the ordered pair for the following reflections. They want us to reflect over, again, pay attention to what axis that they want you to reflect over, because you're always going to change the opposite letters or coordinates sign. So if we're reflecting over the x-axis, that means we need to modify the y-coordinates sign when we write our ordered pair. So let's see. If we change that, it's going to become 3, positive 5. Now to check to make sure you've done it correctly, it's a good idea to maybe sketch a quick coordinate plane and just sketch out those ordered pairs if you know how to plot a point, which at this point you probably do. So we started at 3, negative 5, and I'm just going to sketch it out. 3, negative 5 would take us to the left 3, or excuse me, to the right 3, and then down 5. So we'd be approximately right there. Okay, and if we're going to do our change here to 3, 5, I'll do that in red. Here's our new point. 3, 5 is going to take us the same direction, 3, but this time up 5. Now again, remembering that the horizontal axis here is your x-axis, that means we've correctly reflected it. Okay, notice how it's reflected across that axis, and that's exactly what we wanted to do. So let's take a look at the next example here, negative 2, negative 6. They want us to reflect that over the y-axis. So again, think opposite coordinate. If they want us to reflect over the y, that means we need to change the x, which is right here. So if we're rewriting this ordered pair, it's going to be 2, positive 2 this time, and then we can keep the other coordinate the same, negative 6. Okay, so just to show you one more time, you can quickly sketch it out, and I'll do this one a little quicker. We started at negative 2, positive 6, which would be here, approximately right there. And then now our new coordinate is going to be positive 2, negative 6. Oops, excuse me, I did that incorrectly. Let me go back. There we go. All right, let's get this right. So -2, -6 would actually take us here. So down, left 2, then down 6. So it would be approximately right there. And then our second point this time is going to be +2, -6, which takes us to the right and then down. There we go. So you can see now that you've reflected over the y-axis, again remembering that the y-axis is your vertical axis. Okay? Let's look at just a couple more of those. All right, and you can try them on your own if you have time, or you can still watch. If you're not understanding, keep watching. -2, 7 reflect over the x-axis. That means we're going to actually modify the y-coordinate. All right, so it was originally -2, +7, so our new coordinate is going to be -2, -7, changing that sign. All right, and again, sketch it out if you're not quite sure. For the next one, 4, 9, we're going to be reflecting that one over the y-axis. So again, that means change the other coordinate, which means the x coordinate. So it's a +4. We're going to make that now a -4. And then the y will remain the same, -4, 9. All right, and you'll find that that successfully reflects them over the axis that they're asking you to reflect them. All right, next what we're going to take a look at is reflecting shapes, okay, actual shapes on the coordinate plane. This is a square, and they want you to reflect this across the y-axis. So again, they're wanting you to take those points and reflect them across the vertical axis, which would end up putting that shape in that general area. But we can't just say that without actually putting them specifically where they're supposed to go. So you have a couple of options here. Because they're giving you the visual of the actual coordinate plane, you can use that to your advantage because we can find the coordinates by using the graph. So for instance, this first point, I'll call that my first point. We're going to find the coordinates of that point. That is going to be -2 on the x, +2 on the y. So -2, +2. All right, then we're going to do the same thing for the next point, which will be right here. I'm going to do -5, +2. Okay, and as we go around finding the rest of our coordinates, the next ones will be -5, +5. We'll say that's the next one there, -5, +5. Oops. All right. And continuing then, for the last point will be -2, +5. All right. So the reason why we did that is because we're going to use the same strategy that we were using just a moment ago. Remember, we're reflecting over the y-axis. Now that we have all of our coordinates listed here, we can take that information and, remembering how to modify them, just make the changes necessary. So when we reflect over the y-axis, what do? We change the other coordinate. By other, I mean the opposite. So we're going to be changing all of the x coordinates of these points to the opposite sign. So I'll do that off to the left here. So the first point then would become 2, +2. The next point would become 5, +2. Then 5, +5. And finally 2, +5. So you can see once you get all of your original points listed, if you remember what to do, it's not too bad because you're just changing signs and that's all. And then of course, if you have access to a coordinate plane like we do here, you can double check to make sure. So let's plot those really quick. 2, 2 would be right here. All right, 5, 2, right 5, up 2 would be right there. 5, 5, right 5, up 5. Make sure I place that in the right spot. There we go. And then finally, +2, +5. All right. And though my little points there are a little skewed a bit, you can see that that would be a direct reflection over the y-axis, which is exactly what they wanted you to do. All right. Let's take a look at another one of those. This time they want you to reflect this quadrilateral, which appears to be pretty much a trapezoid, okay? This time they want you to reflect it over the x-axis, but we're going to use the same strategy as before. Let's go ahead and find our original coordinates first, then we'll make the modifications after that. So let's start with this point here, all right, the coordinates of that first point would be +1, +2, because we're going right 1 and then up 2. All right, the next point, this one here, will be right 3, looks to be up 5, 3, 5. All right, and then the next point, we'll just keep moving clockwise there. We're going to go to the right 5 and up 5 to get to that point. And then finally, the last point here will be right 7, up 2. Okay, and keep in mind the order in which I'm doing that when I write my ordered pairs. I'm always going along like right or left first, depending, then up. It's always x coordinate, then y coordinate every time. So now, looking at what the directions are asking, we can now go ahead and make the changes to our coordinates that we're being asked to make. So we're wanting to reflect this over the x-axis. So again, keeping in mind our rules here, if we reflect over the x-axis, we need to change the other coordinate, which means the y coordinate. So starting with 1, 2, the other coordinate would be 2 in this case. So 1, -2. 3, -5. 5, -5. And then finally 7, -2. Okay? So again, and you can quickly plot those to make sure that you're in the correct spot. So 1, -2 would be right here. 3, -5 would be right here. Right 3, down 5. All right, then 5, -5, right 5, down 5. And then finally 7, -2, which would be right 7, down 2. And you can see you get your reflection over the x-axis, which is exactly what we wanted. Okay? All right, let's take a look at distance. You can also find distance on a coordinate plane, and for right now, distance is going to be a little bit more basic, which means you're going to be just dealing with points that are either directly vertical of each other or directly horizontal of each other. And this is usually pretty simple if you're given a graph like you see here, because you can plot the 2 points and simply count how many places it takes you to get from one point to the other. However, I'll also show you a couple of strategies you can use if you don't have a graph available. So here, I'm going to go ahead and mark where my house would be on this coordinate plane at -2, 5. So again, just remembering your basics of plotting a point, you have an x and a y. So we're going to move along the x to -2 and then up 5. 1, 2, 3, 4, 5. So there's approximately where my house would be. And then my school would be at 8, 5. So I'm going to move 8 places to the right and then up 5, which puts me approximately right there. Okay? So, like I said, because we have a coordinate plane available, we have both our points. If we want to find the distance between the two, we simply do some counting. So I'm going to count from that point, my house, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. Okay? So the distance for this between these 2 points would simply be 10 on the coordinate plane. All right? Now, I'm going to give you a couple strategies, again, like I said, for if the coordinate plane is not available. If the coordinate plane is not available, what you need to do is look at your coordinates that are the same. So we have -2, 5, and you have 8, 5. Notice how your y coordinates are the same. Okay? The reason why I draw your attention to that is because that means you really can't do anything with those. If they're the same, adding and subtracting is not going to be really helpful. So you can ignore those for right now. You find which ones are the same, and then you draw your attention over to the other two. -2 and 8, okay? If the signs are different like this, what you have to do is add the two numbers. Now you can ignore the sign. The sign isn't going to play any part in this. I know that the 2 is negative, okay? But just add them together. Notice what you get. If you add 8 and 2, though I know the 2 is negative, don't worry about that. If you add 8 and 2, notice what you get. 10. Now if the if the two numbers had the same sign, then you would actually subtract, and we'll get into that. The reason why we add here is because the 2 is negative. All right, so we're going to look at some examples in just a second and practice a little bit of that, and I'll remind you of those rules because I know they can be a little confusing. All right, so let's look at this example here. It says, what is the distance on the coordinate plane of the point 5, -3 and 5, 8? Okay, so looking at these two, we can see we don't have a coordinate plane, first of all, and we can see that the x coordinates are both the same. So the rule, again, same. If they have x coordinates are the same and your other coordinates have different signs, so notice one is negative and one is positive. All right, if that's the case, then you actually have to add the two numbers. Now you're not adding them as though it's a negative, however. It's called adding the absolute value. So if you've learned what absolute value is, that should make sense. That means you're just adding 3 plus 8. Okay, if you haven't learned absolute value, you can see that on another lesson. So ignore the negative sign and add the two numbers, and you'll see that the distance on the coordinate plane of these numbers would be 8 plus 3, which is actually 11. Now again, if you get confused or you think you're not quite sure, you can always draw it out, plot the points, and count it. That's always a good backup plan. What I want to show you real quick before we move forward, though, is what happens. Let me modify this to 5, 2, and let's say the other point would be 5, 6. What if you have a similar problem like this, and you see now this time the y coordinates, or the x coordinates, excuse me, are still the same, so we can ignore those. Put that back there. We can ignore the 5s because we're not going to use those. We're always going to use the other numbers that are not alike. What if the signs are the same? In this case, both positive. Well, this time, instead of adding, what you'll actually do is subtract. Okay? So to find the distance between these 2 points, you'll see that it's actually going to be the larger number minus the smaller number, which is simply 4. Okay? And those are just two little tricks that you can use. Again, if you need to go back, rewind, to kind of get used to that, you can do so. That's fine. But let's take a look at a couple more here. And these are just different types of examples you're going to see throughout this type of a section. What would the coordinates be of the missing point on the rectangle? Well, the key to a problem like this, of course, is the shape. Okay, you have to be familiar with what a rectangle is. Hopefully you are. You know that they have two sets of parallel sides. Okay, so if we were to draw this out, this side would be parallel to this side, and this side would be parallel to this side. Okay, so there's a particular place that this missing point should be based on that information. And it is as simple as you would think that it is. You just need to look and figure out approximately where that point would be, or exactly where that point would be, horizontal to that bottom point, which is this point here. So let's take a look. If we're going to line up our point along this x coordinate and y coordinate with these 2 points, we need to figure out where it would fall here and here. All right, so knowing that, we can place it directly where it would need to go, which would be right in that vicinity right there. All right, and if they want the actual coordinates, which they do, then you need to give those coordinates. In this case, you're going to have to move across 8 on the x-axis and down 6. So your coordinates here would be 8, -6. Okay, so you just have to make sure that you understand what a rectangle is and place it where it needs to go. All right, with this next example, we're going to be looking at finding the missing point again. Okay, so they want us to find the missing point, but this time of a parallelogram. And again, the key is understanding the type of shape that they're asking you to find. So in this case, a parallelogram, though it could appear to be a trapezoid where the line would come in this way, that's not going to be the case. A parallelogram is going to look more like this. Okay, where you have parallel sides that run horizontally. They can also run vertically, but then these other two sides are more of a slanted version. Okay, but they're also parallel. So we're going to be using the side, or the 2 points that are already there, to help us find our missing point. These 2 points that are already there will help guide us in finding our next point. All right, so I'm going to use a little counting strategy. I'm going to start from this point here, okay, and I'm going to count down 1, 2, 3 places, and then over 1. And notice that those are the directions that get me from one point to the other. So I'm going to use that to my advantage to find our missing point. I'm going to start with the top point. I'm going to do the same thing. I'm going to count down 1, 2, 3, and then left 1. And that'll give you the specific place of your missing point. All right, and again, you can always draw it out just to make sure that everything looks the way it's supposed to look. There you go, and you end up with your parallelogram. All right. Thank you for joining me. This has been a quick tutorial on coordinate plane, distance, and reflections.